Hello and welcome to my kitchen counter. This is going to serve as the control portion of your DHMO lab, or your dihydrogen monoxide lab, more commonly known to you as water. And at this point, you've probably done all of the procedures using water. The point of this lab is for you to see that there are clear liquids that exist at normal pressures and temperatures found on Earth's surface that act really differently than water. Water is unique in a lot of ways. So water is your experimental group. It's what you're testing and you're investigating, and I'm going to show you a control. And the liquid that I'm going to use as a control is rubbing alcohol, isopropanol or isopropyl. And I couldn't send you home with this because, one, it's illegal, and two, I figured that I could do this video. I'm not sure if you can even find this in the store at this point because of COVID. So what we'll do is we'll go through all of the stations and you'll get to see how alcohol behaves versus water. Now, the alcohol that I'm using has a different molecular formula than water. It has 3 carbons bonded to 7 hydrogens and 1 oxygen. So those different atoms and the way they bond gives it a different chemical property, different reactivity, different behaviors. So that's really what we're trying to see here. So the first thing I'm going to do is the drops on a penny. You wanted to see how many drops of water would stay on a penny until they fell off the side. So I'm going to do the same thing with alcohol. So we'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 25 is when they fell off. So the second I put the 26th drop on, it was already falling off the sides of the penny. I imagine that you were able to get quite a few more drops of water on your penny than that. So we'll move that aside. I will wipe down the counter and we'll go to the next station. The next station is where you put a drop of water on the counter and you watch to see how long it took to evaporate. So I have my eyedropper of alcohol. I'm going to put a drop right here. I don't know if you can see it, but I can. And we are at minute 225, so we will check back when we're done with this lab to see if it's still there. The next portion of this lab looked at dissolving some salt in water. So I'm going to take half a teaspoon of salt, which is sodium chloride. And I'm going to put it inside of this container of alcohol and stir it around to see if it dissolves. I feel like I have a cooking show. So with my pipette, I'm just going to swirl it, and you can see that it's sort of resting on the bottom here. And normally, if you have a material and you want to dissolve it in water, you just sort of agitate it to get it in suspension and promote dissolving. But that doesn't seem to make any difference. We still have the salt sitting on the bottom. So the salt is not dissolving in the alcohol. Very different than what you probably saw with the water. The third portion of this lab looked at what happens when you put water in the freezer for a few hours or overnight, I think is what I asked. So I didn't have overnight, but I have had most of the day. So I did put some alcohol in a small dish, and I put some food coloring in it just so that you can sort of see the viscosity of the liquid. So if I bring it under here, you can sort of see that it's a little bit thicker than water. It's not completely transparent. There is some suspension in there. So it got more dense, certainly, but it didn't freeze. So if I had put water in there for the same amount of time, you would have certainly seen some of this completely frozen. Now, even if I had left this alcohol in the fridge overnight or the freezer overnight, it would not have frozen completely solid. So it would have become more thick, more viscous, and more dense, but it would not have become frozen. And it certainly would not float. The next part of your lab was to see how water reacted on wax paper. Now, I don't have wax paper here. I have parchment paper, which is pretty much the same thing. So it's a piece of paper which is made of plants that has oils embedded in it so that things don't stick to it. So I am going to put some drops of alcohol on there. And you'll notice that when I first put it on, you see a drop. But then when I go to move it around, it doesn't stay in a droplet. Put another drop, try to move it around, no droplets. And I can keep putting those drops on there. No droplets. I can't drag droplets around on top of this. And you'll start to see that the middle here looks like that alcohol is actually absorbing into the paper, which you did not really see the water absorbing into the wax paper. So again, different behavior with this clear liquid than water. Now last but not least, you had the plants, and whether you had to go to the grocery store to find them or you went outside, I went outside and I found these white flowers. These are asters, A-S-T-E-R-S. They're members of the Asteraceae family. That's the same family where you could find daisies and coneflowers and black-eyed Susans or even dandelions. And I put them in a container of water, blue water, and alcohol. Or not blue water, I'm sorry, blue food coloring and alcohol. And I've let them sit for most of the day, and you can see that those flowers are still white. So that alcohol did not travel up the stems to the flowers, not from root to shoot, and so the flowers remained white. Now, the flowers that I did have sitting in water tinted with blue food coloring, they shriveled a bit, but you can certainly see up close that those leaves, those petals, are tinted blue. So clearly the water carrying the food coloring traveled from root to shoot in those flowers. So before we conclude, we're going to go back and look for that droplet of water, which is absolutely gone. So it's been about 7 minutes. I started counting around 2.5 minutes. So in less than 6 minutes, we have seen that drop of alcohol completely evaporate. I have no fan, I have no heat on in my house, and the light is up in the ceiling many feet above us. So I imagine that evaporated quite a bit faster than the water. So these are just examples of how a different clear liquid behaves under all of the same conditions as water, so that you can compare the behavior of water back to this. And you can see that water behaves pretty differently and is unique in the way that it behaves. Many other liquids do not behave like that. And what we're going to do over the next few classes, or at least this class, is try to understand how those unique behaviors allow for life to exist on Earth. Have a great night, kiddos.